So today we're going to be looking at something called a Lewis structure, and what a Lewis structure does is shows the bonding between the atoms of a molecule. What we're going to ask is, where are the electrons? And we know from a couple of different web quests that we did that electrons are involved in bonding because atoms are trying to fill the valence. That's why noble gases don't react. And so that means we have a situation like this. Here we know that the sodium atom has one valence electron in its outermost energy level. That's right here. And chlorine has 7. You can see them right here. 1, 2, 3, 4, 5, 6, 7. So to get access to 8, everybody wants 8 in the valence. What sodium does is donate 1 electron to chlorine, and that means that chlorine now has 8 electrons in the valence, and because sodium has lost that 1 extra one, it also has 8 electrons in the valence. So let's take a look. We got some simple rules we're going to follow here. And so in a Lewis structure, what we're going to do is try to track where the electrons are. Let's take a simple molecule. Here's one called carbon tetrafluoride. And the first thing that we're going to do is count the valence electrons involved. And so we know that carbon has 4 electrons in the valence, and there's a total of 1 of them in the molecule. And we know that fluorine, they each have 7 electrons in the valence, and there are 4 of those in the molecule. That means we have a total of 32 valence electrons that we're considering. Our second step is we're going to create what's called a skeleton. And the skeleton is going to use a pair of electrons to form each bond. So a skeleton for this particular molecule would look like this. We'll have a carbon in the middle. We'll put the atom we have the fewest of in the center. So carbon goes in the middle. We have a fluorine here, a fluorine here, a fluorine here, and a fluorine here. And we've used a pair of electrons in the bonding. So each of these lines represents 2 electrons. So now how many valence electrons do we have left? Well, we used a total of 2, 2, 2, and 2 electrons for the total of bonding, and that means that we've used up 8. How many do we have left? 24. So what we're going to do with these remaining electrons is we're going to fill the valence of the outermost atoms. So we'll use the remaining electrons to fill the valence of the outermost atoms. So in this case, we'll take these 24 electrons that are remaining and we'll fill the valence of each. So here's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We've used up 12. 1, 2, 3, 4, 5, 6. We've used up 18. And 1, 2, 3, 4, 5, 6. So what we now have is each fluorine with access to 8. This fluorine has access to 8. This fluorine has access to 8, and so does this last one. And involving all the electrons that are shared, the carbon has access to 8. Let's try one like this. This is a molecule of Old Buddy water. So we'll draw our skeleton, and first we want to find out how many total electrons we have in the bonding. So the hydrogens each have 1, and we have 2 hydrogens involved. The oxygens each have 6, and we just used 1 oxygen in this molecule, so we have a total of 8 electrons involved. So here's our skeleton. We'll put our oxygen in the middle, and we'll bond each of our hydrogens with a pair, and that means that we've used 4 electrons in the bonding. We have 4 left. Now normally we'd fill up the outermost atom's valence electrons, but the hydrogens can only hold 2, remember. So we can't put these extra electrons in the hydrogen. So what we'll do is we'll take these extra electrons, we have 4 left, and we'll put them around the central atom. So we'll put extra electrons around the central atom. And that's going to look like this. 1, 2, 3, 4. If you're counting, the hydrogens can only hold 2, so they're fine. And the oxygens now have access to 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's one more trick that's useful. This is a molecule of carbon dioxide. If we're going to do this skeleton trick, our carbon has 4 electrons and there's 1 of them. The oxygens each have 6 and we have 2 oxygens, and so we have a total of 16 electrons in the bonding, 12 from the oxygen and 4 in the carbon. Our skeleton is going to look like this. We'll put the carbon in the middle and an oxygen to either side. We've used up 4 electrons in the bonding and we have 12 left. So we'll fill the outermost valences with 6 electrons for a total of 8. So now this oxygen has access to 8. This oxygen has access to 8. But if you notice, this carbon only has access to 4. So a nice trick that we'll use is we'll take a pair of electrons from this oxygen and put them here to make sure that this carbon has access to 8. We'll do the same with this pair of electrons and we'll put them here. This is called a double bond. And if you're counting, you can see that this oxygen has access to 8, this oxygen has access to 8, and this carbon has access to 8. And that's all we do. So let's take it for a spin.